Good day, students. Welcome to math.serve.com. In this clip, we are going to be going over an example on how to use the mean value theorem. Do not forget to visit our website at math.serve.com for access to a wide variety of math tutorials ranging from algebra all the way to calculus. All right, so for question number 1, we are to find the C that satisfies the conclusion of the mean value theorem. In the problem for number 1, we have the function f of x equals x to the third minus 4x squared plus 5x minus 2 on the closed interval 0, 2. So we are focusing on the conclusion, the C that satisfies the conclusion of the mean value theorem based on the assumption that the two initial conditions are met. Okay? If we look at this function right here, we can clearly see that the two initial conditions for the mean value theorem are met. And the conditions are 1, continuity on the closed interval, and the second one is differentiability on the open interval. Now, if you take a look at this function, this is a cubic function. It has no vertical tangents, no corner cusps or discontinuities. It is smooth and continuous. So we know it's continuous and differentiable on this domain. All right, so we're not focusing on the initial conditions. The assumption here is that the initial conditions are already met. So we just want to find the C that satisfies the conclusion. So what is the conclusion of the mean value theorem? The conclusion is that there is a point where the instantaneous rate of change somewhere in the interval is equal to the average rate of change, which over the interval, so f of b minus f of a over b minus a. All right? So this is what we're going to be solving for, the C that satisfies this equation. Now, a is the lower bound of your interval, which is 0, and b is the upper bound of the interval. All right? So let's divvy up our work into two parts. First one, we want to find f prime of c. Okay, so let's find f prime of c. In order to find f prime of c, we'll just simply differentiate the function and plug in c. All right, let's go ahead and find f prime of x. So we're going to differentiate this function. We know that f of x is x to the third minus 4x squared plus 5x minus 2. Now we're going to differentiate using the power rule. F prime of x equals 3x squared minus 8x plus 5. Okay? Now this is f prime of x. Now f prime of c will simply involve us evaluating the derivative at x equals c. So we're going to have 3c squared minus 8c plus 5. Now we've determined the left side of our equation. Now let's shift our attention to the right side. We want to find the average rate of change, or the slope of the secant line through 0, 2 on this curve. All right? So as indicated earlier, a is 0, b is 2, so we know the values of the denominator. Now we have to determine the values in the numerator. All right, so f of b is the same thing as f of 2. So we're going to evaluate the original function at x equals 2. It's as though we were looking for y2. Okay? So we're going to have 2 to the third minus 4 times 2 square minus 5 times 2 minus 2. All right? If we evaluate this entire expression, we'll end up with um, 0. Okay? We'll end up with 0. So let's correct this. This is a plus. So we have 0. Okay, so that is f of b. Now we need to find f of a. F of a is the same thing as f of 0 since a is equal to 0. All right, so we evaluate this function when x is 0. So we'll plug in 0 into this function, and then we'll have 0 to the third minus 4 times 0 squared plus 5 times 0 minus 2. And then we can clearly see that f of a is negative 2. All right? So we are ready to compute the average rate of change or the slope of the secant line. F of b minus f of a over b minus a is the same thing as 0 minus negative 2 over b, which is 2 minus 0. All right, so we're going to end up with 2 over 2, which is equal to 1. Now let's take a look at this for a second. This value right here is the slope of the secant line, and this is the equation for the derivative of at any point on the original function. Okay, so to find the c that satisfies the conclusion of the mean value theorem, we'll simply set these two results to each other. Okay, so we're going to have 8, actually it's 3c squared minus 8c plus 5, set that equal to 1. Okay, now we have a quadratic equation, so let's go ahead and solve it. In order to solve this quadratic equation, we want to put it in standard form first. So we'll have 3c squared minus 8c, subtract 1 from both sides, plus 4 equals 0. Okay, factor this by grouping. So I am going to be using the x game. So I'll make my little x here. AC goes on the top and B goes on the bottom. Okay, AC is positive 12, B is negative 8. What two numbers multiply to give you positive 12 and add to give you negative 8? We have negative 6 and negative 2. All right, so we have 3c squared minus 6c minus 2c plus 4 equals 0. All right, now let's factor by grouping. From the first two quantities, I can extract 3c. So we have c minus 2. And then in the next two quantities, I can extract negative 2, and we're left with c minus 2. Finish off our factorization by pulling out common factors. Okay, so the common factor of these two terms is c minus 2. Factor that out, and we're left with 3c minus 2. Using the zero product property, we have c minus 2 equals 0, and 3c minus 2 equals 0. If you solve it, you have two c values, c equals 2, or c equals positive 2/3. All right? So are there two c values that satisfy the conclusion of the mean value theorem? If you look at the interval, we have 0 to 2 as the interval. So let's take a look at that. We're going from 0 to 2. The c that can satisfy the conclusion of the mean value theorem must be in the open interval 0, 2. It must be in between 0 and 2. You cannot have 0 or 2. So what does that tell us? It tells us that this value is not a value that satisfies the conclusion. Okay, let's use a different color for that. The C that satisfies the conclusion of the mean value theorem is 2/3 because it sits inside this interval. You may not select endpoints. Okay, so in conclusion, the C that satisfies the conclusion of the mean value theorem, we can call it MVT, is C equals 2/3. Okay, so the slope of the tangent line when C equals 2/3 should be equal to the slope of the secant line. Okay, and the slope value that we're talking about here is the value of 1. Okay, so that's that. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to our channel for updates to other cool tutorials such as this. If you have any questions or would like to request any videos, feel free to include it in the comments section below this video. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day.